Now we'll look at Delinea, another major player in privileged access management. As we go, focus on how its vaulting, least privilege, session control, remote access, and DevOps secrets map to the PAM controls you already know, and how that prepares us for the vendor comparison next. At this point, we've covered the foundation: identity basics, privileged access risks, zero trust, and core PAM controls like vaulting, rotation, and session management. We've also placed Microsoft Entra PIM, CyberArk, and BeyondTrust in context. Delinea rounds out that vendor overview before we compare the options side by side. Delinea is a broad PAM platform for controlling privileged access across legacy infrastructure and modern cloud environments. At the center are familiar controls: credential vaulting, least privilege enforcement, and visibility into privileged sessions. Its strength is flexibility. Organizations can use Delinea for servers, endpoints, applications, databases, DevOps secrets, and remote access, with SaaS, on-premises, or hybrid deployment models. It also integrates with identity providers such as Entra ID, Okta, Ping, and LDAP. That broad coverage is why buyers often compare it directly with CyberArk and BeyondTrust. Rather than viewing Delinea as one tool, think of it as a connected set of privileged access controls. Secret Server protects shared and privileged credentials through vaulting, rotation, approvals, launchers, and session visibility. Privilege Manager reduces endpoint risk by enforcing least privilege and controlling which applications can run or elevate. Server Suite extends privilege control to Linux, UNIX, and Windows servers through command authorization, MFA, and identity-based access. Supporting capabilities cover DevOps secrets, remote access, connection management, reporting, and cloud deployment. Together, these controls support the privileged access lifecycle: secure, control, monitor, and audit. Deployment is another area where Delinea is designed to fit different enterprise patterns. A SaaS model reduces infrastructure overhead and supports global access. An on-premises model gives tighter control for regulated or highly segmented environments. Many organizations use a distributed access model, where gateways, connectors, or agents broker secure access to internal resources without exposing them directly. Identity integration is central. SSO, MFA, and conditional access validate the user before privilege workflows begin. The architecture also needs to protect continuity, with high availability, disaster recovery, and segmentation built in. Secret Server functions as a controlled vault for privileged access. Each secret is one protected item, such as a password, SSH key, API key, certificate, or secure note. Folders give the vault structure, so teams can organize secrets by business unit, application, environment, or owner. Templates make secrets consistent by defining the required fields and behaviors for each credential type. Permissions and policies then determine what users can do: view, use, edit, approve, rotate, or manage. The result is governed, auditable access instead of scattered credentials. A strong secret access model starts with identity groups, not one-off user exceptions. Permissions should map from Active Directory or Entra ID, and users should receive only the capability they need: view a password, use it without seeing it, edit, share, manage, or administer. For sensitive secrets, approval can be required before access is granted, and every use should be recorded. Folder inheritance reduces administration, but it can also spread access too broadly if it is not reviewed. Good governance means named owners, separation of duties, regular certifications, and audit evidence that access remains appropriate over time. This is controlled access without handing over the key. A user requests a secret, and policy confirms they are allowed to use it. Instead of displaying the password, Secret Server launches the RDP, SSH, web, database, or application session using the vaulted credential in the background. Checkout rules can limit who uses the credential, for how long, and whether simultaneous access is allowed. When the session ends, the credential can rotate immediately, or later by schedule or incident response policy. The audit log preserves the full chain of activity. Privileged access should not be a permanent entitlement. With Delinea, a user requests access to a secret or system, and policy determines whether approval is required. That approval might come from a manager, system owner, security team, or a combination of them. The request can also be checked against conditions such as an approved time window, business justification, ticket number, and risk level. Once approved, access is granted just in time for only the required period. When the window expires, access is removed automatically, and every decision is captured for audit and accountability. Session control makes privileged access observable and accountable. Instead of allowing an administrator to connect directly to a server, database, cloud console, or network device, Delinea can broker the session through a controlled path. That path can monitor activity, record what happened, capture commands or keystrokes, and terminate risky behavior when policy requires it. This creates stronger forensic evidence and cleaner audit trails. At the same time, monitoring must be governed carefully with clear retention, privacy, legal, and regulatory rules so oversight protects the organization without overreaching. Server Suite brings privileged access control down to the server layer. Rather than relying on shared root or administrator passwords, access begins with a named identity, such as an admin, DevOps engineer, or SRE. Policies determine what that person can do: log in, elevate privileges, run specific commands, or reach sensitive systems. Those controls apply across Linux, UNIX, and Windows servers. Because actions are tied back to individual users, privileged sessions become easier to audit, record, and investigate. The result is less shared account risk and stronger accountability. Policy-based elevation turns privilege from a broad entitlement into a controlled decision. When someone requests a privilege command, policy checks who they are, where they are running it, what command is requested, when it happens, and the current risk context. The outcome may be allow, deny, log, or restrict with approval. This is how least privilege becomes practical. An operator might restart Nginx but not edit sudoers. A security admin might view logs without installing packages. Every decision is recorded, giving teams evidence for audits, investigations, and misuse detection. Consider a finance user who needs to update approved tax software. Without controls, the easy answer is local admin rights, but that also gives malware and attackers more power. Privilege Manager changes the pattern. The user stays a standard user while policy decides which applications, installers, scripts, or admin tools may elevate. Trusted tasks run with the privileges they need, and untrusted or unknown software is blocked from gaining elevation. The result is lower malware impact, fewer lateral movement opportunities, reduced help desk tickets, and an audit trail for every elevated action. In real environments, privileged access is not always an administrator logging into a server. It may be an API key in a pipeline, a contractor needing temporary access, or a cloud administrator responding to an incident. Delinea helps centralize control across those moments by protecting secrets, brokering remote access, and connecting with tools like CI/CD, ITSM, and SIEM. That means safer automation, cleaner audits, and less exposed infrastructure. Delinea's key value is breadth, vaulting and rotation through secret server, least privilege across endpoints and servers, session visibility, and hybrid deployment support. It also connects into enterprise and DevOps workflows. With that foundation in place, we can now compare CyberArk, BeyondTrust, and Delinea using practical criteria: architecture, controls, integrations, usability, cost, and operational maturity.